Uh, Hello everyone. So I am Adi and welcome to my channel. So here are we in the another new video. So in today's video, I am going to cover about just a second. So yeah, in today's video, I am going to cover about hashing and collision. What we're going to study is hashing and collision. So before going to the definitions of hashing and collision, let's first understand a basic things like what we did studied in the previous things like data structures like linear array. Previously we have studied like linear array, right? In linear array what we are doing is we are creating an array of size, for example say n size, correct? In what we were doing is, for example, if we want to search any number, for example say 7, and my array is 1 2 3 4 5 6 7, and for example I want to search the seventh number in this index. So here you can see 7 is occurring at the last index. So maximum time complexity that is going to go in the linear search is O of n. Correct? My maximum time complexity of searching an element in linear array is O of n. Then we came up with a solution that is binary search. As we have studied, just a one thing in binary search, what we were doing is we are taking a sorted array. Correct? We are taking a sorted array. We will take same array 1 2 3 4 5 6 7, and in binary search we were able to reduce the time complexity to O of log n. Right, now from O of n we reduce the time complexity to O of log n. Now as engineers we demanded that we want to search an array, or we want to search an element in O of 1, correct? Like we don't want to spend any time on searching a element, or either traversing through the array or anything. I want that my seventh number, if I want to search 7, it should be come up in O of 1 time complexity. So for example, what we can do is, for example, we can say, okay, if we want to search 7, let's declare an array of size 10. I am generally taking, let's declare an array of size 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, we have declared 1 2 3 4 5 6 7. Each index have their own indexes like 1 2 3 4 5 6 7 9 9 10, and if we want to say like we want to search 7, then 7 will be present at index 7, like this index is 0 1 2 3 4 5 6. As you can see, 7 will present at 6th index. For example, if I want to search say s, then it will be present at what index? S minus 1. We can directly return this index. So here you can see we have reduced the time complexity to O of 1. So for example, you can say we have numbers from 1 to 100, right? And we want to search 59. Then we will declare a 1 to 100, and 59 will be present at 58th index. 58th index will be equals to 59, right? But now here's the problem that occurred in this method is, like for example we have, you can say, numbers from 1000 to 9999, correct? We have 8 999 numbers, and we want to search any number in this with O of 1 time complexity, correct? Now the solution that we have arrived is either to declare array from 1000 to 9999, right? So we will declare an array of size like we will declare an array from size 0 to 10,000, correct? We will do this thing, but as you can see we have to, my 1000 index are going waste. For example, as you can see, before 1000 there is nothing. Also, for example, say we have more bigger number, like you can say we have more bigger number, then what we are doing? We are basically wasting our space, correct? Then just a second. For example, let's look at one thing. For example, I have three numbers. One is 8. Yeah, my bad. We have three numbers, 8. We have other number is 100. Other number is, for example, say 500. Now I want you to store it in such a way that any number I want, I can get it in one time complexity. Now you will say, okay, let's find it the maximum element of these three numbers, and we will create an array up to 500. Array up to 500. Now if I search any element in between this, it will give me up to O of 1. But you will see here for only three numbers, we have created an array of size 500. And for example, if I take the size of one integer element is 4 bytes, right? 4 into 500 is taking 2000 bytes per se. Now you will see for only for three numbers, we have to create 20,000 extra bytes. So what is the solution? That we will also take less memory, and we can also find any element in open time complexity. Then here comes the concept of hashing. Alright, now let's study in deep about hashing. So what basically hashing says, in hashing what we are doing is, we are basically you know uh, assigning an index to each and every number. For example, here I can say I have 2, 10, 22, 25, 30, correct? Here I have taken 5 numbers. For now, just understand, like to 2 I have assigned 0, to 10 I have assigned 1, to 22 I have assigned 2, to 25 I have assigned 3, to 30 I have assigned 4, correct? We have 5 numbers and I have assigned each unique index to each and every number. Now if I want to say, like if I suppose I want to say 25, correct? I have say search for element, I say search for element 25. Now I know the value of 25 is 3. I will check into my array if at my third index there is element present or not. I can see at my third index 25 is present, so I will return true, correct? Now here the main part of this question arises, like here I have indexed I have taken a random, I have given random values to all my elements. But for example, how for large numbers or for big data sets, how we will assign each unique index to all my elements? For that we have came with the solution, that is, now here comes the part. Just a second. Here comes the solution, that is hashing. So yeah, let's try to understand hashing and with some real life example. Okay. So for example, we have different numbers like 72, then we have 27, then we have 63, then we have 44, then we have 65, then we have you can say 11, then we have 29. Okay, we have this much array. Now for example, I will do one thing, like I will create an array of size 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Now what I will do is I will derive a formula. For example, I have values. What I will do is for each value of index, right, I will define this a hash function. We call this hash function to find or to get the index value of each and every element. Now I will do is, we have what is value, index value mod 10. Here I have taken 10. We generally call this mod value. You can take this mod value anything. Generally in heaps or sorry, in hashing, we take usually prime numbers. We usually take prime numbers as our mod value, but for simplicity here I have taken 10. Now I have number, first number is 72. If you do 72 mod 10, it will be 2. So for 72 I got the index 2. Now I will store 72 at my second index of array. I will define indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 72 will be at second index. Similarly 27 will be at 7 index. 27 mod 10 is 7. 63 mod 10 is 3. 44 mod 10 is 4. Then 65 mod 10 is 5. Then 11 mod 10 is 1. 29 mod 10 is 9. And here where I don't have anything, I will declare it as -1. Correct? Now for example, I want to search an element that is 27 only. Right? Now our hash function was value mod 10. I will do value mod 10. 27 mod 10 is 7. Now I will go to at the 7th index of my array that we have taken up. I will see if there is anything. If there is -1, then return false, and if there is a value, then return true. We can see here is value is 27. Then what I will return is I will return true. Now similarly, for example, I will say search 10. Correct? Now value mod 10. 10 mod 10 is 0. Then I will go at my 0 index of that array. There is -1, so there is no element present at that particular index, so I will return false. I hope now you got the point of hashing. What we are doing is basically we have set of values, and we are assigning unique unique index value to each and every element so that we can access or we can find them in O of one time complexity. Now here comes the catch. As you can see here, each and every element is giving different value when I am doing mod 10. Correct? But for example, just say I have another value that is in here. I have another value that is let's add some value that is, for example, say 35. Correct? I have another value that is 35. Now 35 mod 10, what it is? It is 5. Correct? 35 mod 10 is 5. Now the index value or the hash value of 35 is 5. Now but we will go to our index, this. As you can see, there is already element 65 present in my index. So what you are saying is, for two values, for example 65 and 35 have the same value, right? So this concept is called collision. Why? Because the hash value or the index value of 65 and 35 is same. Correct? For example, if I want to search 65, right? If I want to search 65 but I have stored 35 there, then it will collide, because I am searching for 65 but I am getting the value for the my 35. Similarly, in other such way, for example, we have a large set of numbers. If we do same thing, then there are multiple collisions can occur. For example, we have 22, we have 32, we have 42, we have 12, we have 72, we have 82, we have 92. You can see if we go from the same index or hash value, our hash value function that was hash value equals to value mod 10. For each and every value, the hash value will be 2. So you can see for all the values, my hash value is coming 2. Correct? So what we have to do is we have to take some particular precautions. I guess I wrote the precaution spelling wrong. Precautions. Yeah. So we have to take particular precautions that we can avoid collision and get unique values for each and every element, right? I want unique set of values for each and every element to identify them in of one-time complexity. Basically, here is the catch. Like, what is the objective behind hashing? What is the objective behind hashing? Right? You must know this. What is the objective behind hashing? First, search, insert, or delete the values in O of 1. In later concepts, or I will try to cover, you will study like in C++, you will study unordered maps. In Java, that is hash maps, correct? You will study sets, and there are different other data structures that you will study. What are these? These is the concept of hashing. They search, insert, or delete the values in their data structure in O of 1 time complexity, correct? This is the objective of hashing. Now, during hashing, the problem that is occurring is collision, because for element because for any element there might be a hash value or index value that is same for two or more than two elements, right? So now we will understand how we can avoid collision, or how we can do the maximum probability so that collision occur less, or we can define the hash value for each and every element very separately. Now there are many concepts to avoid collision, or to get different range of values. Like for example, in hashing also, if I tell you about hashing, there are different concepts. For example, there is one is double hashing. In double hashing, what we simply do is, for example, here how we are calculating the index value or hash value mod m, correct? We are calculating like this one. But in double hashing, what we will do is we will take two hash, like for example value mod m plus value mod n. As you can see, we have taken two hash values m and n. Then it might give a set of range of indexes which collides less, correct? Then we have different methods, like here we are doing divide, we are doing modulus operation. For example, in other methods you can do multiply. For multiply, what we will do is, how hash value will be calculated, it will be calculated by uh, value into, for example, you have taken very small value, for example 0.97, correct? Now if you multiply, and we are taking the floor of this, floor means it will round off the our decimal value to the lowest integer. Like for example, we have value equals to 10, then 10 into 0.97, it will be 9.7. Then floor value of 9.7 is 9. So our 10th element will store at index 9, correct? Similarly, we have many other methods of doing hashing. Even you can define your own method of doing hashing. You have some method that is giving different set of values, you can define it. It's not a big thing. But now here comes the part. As we can see, collision is occurring. You will read any book, any blog on internet, there is not a single method that came up until now in which collision does not occur. For example, in every method of hashing, collision might occur. Yes, probability might be less for very complex or different methods. For example, we have different in string matching algorithm. In string matching algorithm, you will study Rabin-Karp algorithm. In Rabin-Karp algorithm, we are also using the same concept of hashing, correct? There also the cases of collision occurs. There also the casing of collision occurs, which we I am forgetting the name. When the collision occurs in Rabin-Karp, Okay, I will tell later if I got the name. So yeah, in collision, to avoid collision, or you can say not to avoid, but to handle collision, we have two methods. One is open addressing, and other is chaining method. Both the methods are very simple. I will tell you by a real life example. Yeah, I got the name for the Rabin-Karp algorithm when there is a collision occurs for two set values. For example, like I have given you two values, that is ABC, correct, and other is CBA. Let's understand one thing. I will came to collision methods later. Let's understand this one thing. You will get better understanding. For example, for the value of A is 0, B is 1, C is 2, right? Now for ABC, hash value will be 0 plus 1 plus 2, that is 3, and for CBA also it will be 2 plus 1 plus 0, that is 3. Now you can see for both the values my hash value is coming same. Now while I am doing string matching algorithm, my hash value are same. So ABC is equals to CBA. But when we compare them individually by index to index, it will come different, right? So this concept during string matching algorithm of collision in Rabin, especially in Rabin-Karp, we call this spurious fit. String matching algorithm during Rabin-Karp. We call this method as, or concept as, spurious hit. When the hash values for my substring is coming same and I have to check them index by index, then this concept is called spurious hit, right? Basically this is the live implementation, or you can say the practical problem that occurred in our one of the algorithms. That's why I have gave the example to it. Now let's understand in a very short time open addressing and chaining method. For example, let's take array of size 10. All right, I have elements like 23, 44, 52, 11 and 14, and okay, and you can say 15 and 17. Now my hash value function will be value mod 10, correct. Now for 23 I will generate 0 1 2 3 4 5 6 7 8 9 10. Now for my third, for 23 it will be at third index, 44 will be at fourth index, 52 will be at second index, 11 will be at one index. Now here comes 14. As you can see, the hash value for 14 is 4, but my 4 is already occupied with 44. Now what we will do in open addressing method, we are looking for open addressing. As you can see, we got 14, and when we check the at 4 index, fourth index is already filled with 44. We will traverse the array in forward direction, like what's in forward at 4, that is 5. We will check if there is anything at 5. 5 is empty, so we will assign that value to fifth index, that is 14, correct. What we're doing is, if we got at the index that is already occupied with some element, we will simply traverse forward, and we will see the first empty index we got, we will directly assign that value to that particular index. For example, right now here I have 15. Now I will go to fifth index, correct. Now in at fifth index already 14 is present. Now what I will do forward traversing, then I will assign my 15 value to here. Now here comes 17. 17 will directly assign to 7th index. For example, we have another, that is, you can say we have 71. Now hash value 71 is first, correct, first index. Now we can see at first index 11 is already present. Now in open addressing, what we do, we will traverse forward. I will go to second index, second index also filled. I will go to third, third is also filled, fourth is also filled, fifth is also filled, sixth is also filled, 17 is also filled, and at finally at 18 I got the first uh, I got the first empty index. I will assign my 71 to here. I hope you got the logic of open addressing. This is the simple logic of open addressing. What we are doing is we are simply traversing the array until and unless we find the empty element. Right? This is the method to avoid collision. Alright, then at last we will study chaining method. This is also very a good method, and for me it's the best method to avoid or to handle collision. Now what we are doing is, let's take the same thing. I hope you have studied linked list before, because this logic uses the concept of linked list. For example, we have this array, and you can say we have same hash value function that we have already took, that is value mod 10, correct. Now we have already filled with 1 2 3 4 5 6 7 8 9, you can say 10. All right, this is my 0, this is my first. Let's take this, either otherwise you will get confused. This is nothing. Okay, 0 1 2 3 4 5 6 7 8 9. I have taken an index array of size 10, and at every index my array is filled with elements, like from 10 1 2 3 4 5 7 9 10, and my hash value function is same, value mod 10. Now I come with another solution, that is, for example, say 71, correct. I come with the element 71. What we are doing in open addressing, we are looking at the first index, it is filled, then we are going to traverse to other, then other, then other, then other, then other, then other. Now in this case you can see until till the end point there is nothing. So engineers thought, why to traverse up to n, or why to traverse up till nth element. For example, say if the array is filled, you have to traverse until n, and now the same time complexity occurred. We are reducing the time complexity from on to O1, but here also we have to traverse O of n to find the empty space. So what smartness we have done is, at the first index only, we have created a pointer of next, that is 1, and we are doing is we are initializing it to 71. Don't get confused this. Here what we have simply done is struct, we have created a simple node basically, where int is data, like we simply do it in linked list, and other is node star uh, next, that is null. For example, if I say for each and everything, there is null, null. I see for all the values we have the next as null. As soon as we get the collision, as soon as I got the element with same hash value, I will say create another node, create new node for value, that is 71, and assign the next pointer of first index to this particular node. Now what will occur? My first my point node of first element uh, will be at 71, correct, and the next of 71 is right now null. For example, we got another value, that is we got 66, correct. We will see at sixth index, is there an element. Now you can see sixth is already filled with element, that is 6. Now what we will do is we will create a new node of value 66 and assign my sixth next pointer to that 66 value, and now my 66 will be null, correct. For example, you another got value 46, it is also sixth index, correct. Then it will check at the sixth index, it is filled, then it will check next pointer is also not null, it is also filled with 66. It will check another pointer, it is null, it is empty. So we will remove null, and we will create a new node of for a value 46, and we will assign next of 46 to null. By this method, we can avoid the open collision. Correct? I hope you got the concept of this collision. We have studied about hashing, we have studied about the collision then. Correct. I will try to come up with some solutions or with some arguments, like with some questions on this that can definitely help you, like on another maps on sets and hash maps, etc. But for now, we have studied about the basics of hashing and collision. I hope you understood the concept. If you have any doubt, you can directly comment on my video link and we will see what else we can study about this. Correct. So thank you so much for spending your time, for looking my video, for watching my video. Thank you so much. Signing off, Adi Jain.